Welcome, my friends, to Dr. Frank Cutting Edge Medicine. I'm your host, Dr. Frank Miller, coming to you from San Antonio, Texas. I hope you made the time change, spring forward to daylight savings time. Now you'll have more daylight hours after work or school to get in some walks, work in your yard, plant your garden, or soak up some more of those good sun rays, which are so important for a healthy life. But what happens when the sun goes down? That's also extremely important, and today we are so fortunate to have an internationally recognized expert in melatonin to speak with us. So before we introduce him, let us pray. Good and gracious God, you created the day and the night, a time to be active and a time to rest. Help us to understand the importance of these circadian rhythms so we can be as healthy as possible. We thank you, God. Amen. Okay, so this show, as we mentioned before, is brought to you by O3 Plus Texas. That's our ozone health and wellness clinic here in San Antonio, Texas. The phone number there is 210-558-7778. And as we will be talking about melatonin, we do sell melatonin there in special difficult to find dosages, and we'll go over that in a little bit. Everything that we talk about on this show, we will have links posted to it on our radio website, which is www.drfrankcuttingedgemedicine.com. That's DRFRANK, cuttingedgemedicine.com. And then you can go there, click on links for previous radio shows, find out more about what we do at the Ozone Clinic, and have links to things that we talk about with all the different experts that we get on the show. So now let's turn more of our attention to our internal clocks and what we might do to regulate it, especially as we adjust to daylight savings time. And to do that, I'd like to introduce a really incredible guy, Dr. Russel J. Reiter, Ph.D. Hi, Russ.
Hi, Frank. How you doing, bud?
Great. So I wanted to tell everybody how I met this guy. We have an annual American Academy of Ozone Therapy meeting sponsored by Dr. Frank Schallenberger. And what I like about what he does is it's not just all about ozone. Anything that's healthy, and especially things that you don't hear about all the time because they're not on a commercial, they're not a pharmaceutical agent that they make a lot of money on, then he presents experts on these things and we learn about it. And Dr. Reiter came to one of the meetings, I think it was probably about 7 years ago, and I was pretty well blown away with a lot of things that he said about melatonin. And I learned a lot, and there's so much more to know. So a little bit about Dr. Reiter from what I got online, and then he can tell you more. He's over at the UT Health Science Center. He's been there for probably at least 40 years, I would bet. Is that right, Russ?
Before you were born, Frank.
All right. Well, and then you've gotten a lot of awards. Let's see, 3 honorary Doctor of Medicine degrees, the Presidential Distinguished Scholar Award from UT Health, and I think you have done published over 1,600 research articles. Is that correct?
Something like that.
It's pretty impressive.
Well, that's what I do.
Well, tell us about, so for people who don't know anything about melatonin, what is it and where does it come from?
Well, what most people realize that it's produced in a small part of the brain called the pineal gland. And melatonin is uniquely generated in this organ at night. So it releases melatonin, so your blood levels of melatonin are roughly 10-fold higher at night than during the day. And it feeds back on the biological clock to set your circadian rhythms. It's very important to control circadian rhythms. Unfortunately, as you age, you lose your melatonin rhythm, and we think that accounts for a lot of the circadian disturbances in the elderly people. They are sleepy during the day, they can't sleep at night, and they have other circadian disturbances. So melatonin, best known from the pineal gland in the brain.
Now, I was reading some of your articles, and I'll post one on our website. This one was called Melatonin as an Antioxidant, Under-Promises but Over-Delivers from 2016. So it has a lot of other functions, apparently.
Melatonin has a lot of functions. I don't think actually sleep and circadian rhythms is its essential function. In other words, melatonin existed 3 billion years ago, not million, billion years ago in bacteria. And it evolved subsequently as an antioxidant and co-opted other functions as it became, as it evolved up the scale. Melatonin is a very potent antioxidant, much better, for example, than vitamin E, vitamin C, by virtue of the fact that its solubility goes throughout the cell. Some antioxidants are localized within the cell, so they only protect there, but melatonin is distributed throughout the cell.
So what do we make it out of? It's a protein, or what is it?
It's an amino acid. Well, it's a derivative of the amino acid tryptophan. Tryptophan is an essential amino acid that you eat in your diet. By essential, I mean it's not produced in the body. You have to consume tryptophan. But after it enters the body, it's a very short process to the production of melatonin, 4 steps, and melatonin is produced. So, and remarkably, it's part of the serotonin pathway. Tryptophan is converted to serotonin, and serotonin is then converted to melatonin. 2 steps on either side.
So is that why if you eat a Thanksgiving turkey and they say it has a lot of tryptophan, you're supposed to get sleepy?
Well, they claim that, but anytime I eat a lot, whether it's turkey or not, you get a little sleep. In other words, yeah, tryptophan is the essential, of course, component, but I don't think there's a strong relationship between turkey tryptophan and sleepy, but most of us, after a good hearty meal, feel a little sleepy.
So why does it decline with age? Do we know why?
Yes, we do. What happens is, I told you that the pineal gland is very unique as an organ. People talk about the pineal and melatonin being a hormone. It's really not a classic hormone, and the pineal is not a classic endocrine gland. It's regulated by the nervous system, particularly by information that enters the eyes, obviously. I told you there's a circadian rhythm in melatonin regulated by light and darkness.
Is that suprachiasmatic nucleus?
That's the suprachiasmatic nucleus. That's your biological clock. It's right in the brain behind your eyes, and there's specialized cells in your retina that mediate the effects of light on the clock. It's not your rods and cones. It's a whole different set of cells. Not very many, but they're very important. What happens as you age, the innervation or the fibers that go in the pineal gland destroy the receptors on the pinealocyte, and as a consequence, the pinealocytes or the pineal gland cannot respond to the information it receives, so it cannot produce melatonin. So melatonin goes down. And we think the loss of melatonin with age is consequential in many different conditions. Not only sleep disturbances, circadian rhythm dysregulation, but also antioxidant and cancer and neurodegenerative diseases.
Well, let's go into those areas. I do remember, well, you mentioned something about stroke in your talk years ago as well, and so it sounds like it can protect a lot of organs in the body. For sure.
Of course, stroke, like many conditions, including COVID, for example, COVID infections, they are high free radical conditions. Free radicals do a lot of damage. They are derivatives of oxygen. And the function of antioxidants is to neutralize free radicals. When you have a stroke, there's an area of your brain that becomes hypoxic with deprived of oxygen. And that generates a lot of free radicals. And of course, if you can take a good antioxidant, it would be very helpful to reduce the amount of damage that ensues. The issue is, I think you mentioned it somewhere in a message to me, that a lot of these have been tested in animals, but not in humans. There is one clinical trial going on with melatonin and stroke in humans, but the results are not yet available. But the animal studies are very clear. But you understand there are many places there where you have ischemia. A heart attack is nothing more than a stroke, but in the heart. And again, animal studies have shown that melatonin can reduce the amount of damage to heart muscle after an imposed heart attack by up to 60%.
Wow.
We've also published one paper in the American Journal of Cardiology on a trial we did in Spain, where we infused, when you have a heart attack, the blood vessel constricts or is obstructed and you get ischemia downstream. And what you do is you put in a balloon called balloon angioplasty, open that blood vessel, and the blood rushes back in. At the same time, we injected melatonin directly into that anterior descending vessel of the heart. And again, we found that when you do that, you reduce the damage to the heart as a consequence of heart attack, not unlike with stroke. So that study has been done in humans, and there are others that are planned.
And what dose was that? Do you remember roughly?
Yeah, I do remember. That was directly into the heart, and it was 57 micromolar. That doesn't mean anything to your patients because they can't inject melatonin directly into the heart. But let me put it this way. What I said still stands. Namely, if I had a heart attack or a stroke, if I had melatonin with me, I would take it immediately to up my antioxidant capacity. You cannot overdose on melatonin. It's a very safe molecule, and it's not going to do you any harm, and it would very likely do you some good.
So even if you got it IV, you can't overdose on it?
Nope, you can't overdose it. You can't. Many studies, every drug that's available, even aspirin, has what is called an LD50, a lethal dose for 50% of the animals. These studies are done in animals to kill them. And there's a lethal dose for every drug. Certainly all the prescription drugs have one. You cannot determine a lethal dose for melatonin. Even though attempts have been made, you cannot kill an animal, and no human has ever died from too much. The most that's ever been given that I know of to a human is 1 gram, and you are talking about 10 to 60 milligrams. 1 gram, which is 1,000 milligrams for a month, and that was in humans, and there were no consequences of that administration.
Wow. Now, I was reading also that even plants have melatonin?
Absolutely. Every living organism, so far as we know, has melatonin. I remind you that melatonin evolved in bacteria, and some bacteria were ingested by early plants and became part of the plant cell, and they produce melatonin, and every animal cell does as well. In fact, generally there's more melatonin, higher concentrations in plants than in animal cells, because they actually have 2 parts of their cell that produce melatonin. So yes, plants, every plant we know of that's been tested, obviously not all of them have, but every plant that has been tested. And there are 2 plants that have already been genetically engineered to produce increased amounts. One strain of rice and what is called a microtom tomato has been genetically engineered, so it produces increased amounts of melatonin.
And in the plants, is it mainly as an antioxidant, or does it do any diurnal cycles with them?
It's primarily an antioxidant. In fact, plants, if you place a plant or you don't give a plant enough water, you give them too much water. If it's too cold, it's too hot. They have to protect themselves. Plants are very different than animals. Animals can move out of the situation. In other words, they can seek refuge from heat. Plants are here. They cannot do anything. So they immediately, when they are stressed by any means, they greatly increase their melatonin production to protect against free radical damage. In other words, it's a very potent antioxidant in plants as well. And in fact, there's many studies showing that melatonin will also increase productivity in terms of crop yield and so forth in plants. Melatonin is very, very important in plants.
So if you were talking about IV versus oral, do you get the same kind of blood concentrations?
Well, of course, it depends on how much you take orally. Again, the absorption when you swallow it varies greatly amongst individuals. We call it the bioavailability. In other words, if you swallow 60 milligrams and I swallow 60 milligrams, our blood concentrations may not rise to the same level, depending upon what we have previously eaten, what's in our stomach, and so forth. And there seem to be some slight genetic differences where maybe females have a little bit better bioavailability. And it also depends on the functioning of your liver. For example, if you take melatonin with another antioxidant like vitamin E, they are both absorbed, both go to the liver, and they are both metabolized by the same enzyme. So if you take melatonin with vitamin E, you preserve some of your melatonin because the enzyme that degrades it is monopolized degrading vitamin E. So there are things you can do too.
Are there products that have both together?
Not vitamin E and vitamin C that I know of. There are a couple of products that have zinc and so forth, but I don't know any of them that have. I know one individual who produces his own capsules and includes other antioxidants for that purpose.
And let's see, vitamin E is fat soluble. Is melatonin, I thought it was water soluble.
Well, that's the advantage melatonin has. I mentioned that earlier. You're right. Vitamin E is exclusively fat soluble. Vitamin C exclusively water soluble. So they function in different parts of the cell. Melatonin goes throughout the cell. It has water solubility and it has lipid solubility. And that gives it an advantage in terms of the protection against the free radicals. And that's one reason we think melatonin is so good. Not the only, because it does a lot of other things besides directly neutralizing radicals. It also stimulates what are called antioxidant enzymes that remove free radicals. Melatonin does that very effectively.
You know, that was part of what we had heard at the ozone conference because so ozone is a sublethal oxidant, you know, basically.
Right, it is, absolutely.
And then that induces the antioxidant enzyme systems to protect the organism as well.
Right, yeah. You're
pretty awesome. Yeah. So I think, I know Dr. Schallenberger has included melatonin in his cancer treatments when he works with oncologists and whatnot. But I don't see it used a whole lot in oncology at this point. Do you?
Unfortunately, you alluded to something in your introduction. Melatonin is a very good anti-cancer agent, but it's cheap, can't be patented, so the pharmaceutical company has no interest whatsoever. In other words, I don't get me wrong, we need the pharmaceutical companies. They're very, very important for a lot of different reasons, but they prefer not to have molecules that are endogenously produced that they can't patent. Of course, they can produce synthetic molecules that are effective as anti-cancer agents, and they can protect themselves so that everybody cannot use them. Melatonin is a very good anti-cancer agent. It's been used for that purpose for 30 or 40 years already. In other words, that's been known for a very long time.
Other countries are using it?
There are countries that use melatonin as a prescription for other reasons. And, of course, in other words, it's not approved for an anti-cancer treatment so far as I know in any country. It's prescribed for other reasons such as sleep and circadian rhythm regulation and maybe some others. But again, to say it's good for cancer is never been approved in any country that I know of.
I looked it up this morning to see if it was FDA approved for anything, and it's just labeled a food additive.
It is a food additive. Of course, it exists in plants. And, of course, again, I really want to remind your listeners that this is a non-toxic molecule. And if it's going to be used as a cancer treatment, and I don't ever suggest they ignore what their physician says, their oncologist, they should surely take note of that. But melatonin can be a good supplemental additive for treatment. In fact, there's let's take an example. Doxorubicin is a good anti-cancer agent, very widely used, but it has very significant toxicity on the heart.
Right.
So if you take doxorubicin for a period, well, you may get rid of the cancer, but you have very difficult heart failure. And that can be protected because that heart failure or that damage to the heart is free radical based. So there's a lot of evidence that if you take melatonin in combination with these toxic drugs, you can reduce the toxicity of those drugs, which would be very important because doxorubicin is dose limited because of its toxicity. If you can reduce its toxicity, you can actually give more doxorubicin, have a greater anti-cancer effect, and that would be, of course, beneficial. And
that's so similar to ozone. You know, in Cuba, they were doing pre-treatment studies. They gave dogs ozone, one group, and the other didn't, and then they gave them a toxic dose of carbon tetrachloride to knock off the liver, and you couldn't even tell that the dogs who had the ozone even got the carbon tetrachloride. And Dr. Menendez down there feels like if we could do that before chemotherapy, it would be the same effect as what you're describing for melatonin. Mm-hmm.
I think that's a very good idea. You're right. Carbon tetrachloride is a very toxic molecule, particularly to the liver. And we already showed in 1995 that you give melatonin with carbon tet, and again, you reduce the amount of hepatic damage. So you're right. There's a lot of similarities, apparently, between melatonin and ozone.
Now, you're there right in the middle of the medical school. How come we can't get any human studies to show that it helps with heart failure, with heart attack, stroke, stuff like that?
Well, I'll give you an example. Right now, COVID is a big deal. There are probably 50 or 60 papers suggesting the use of melatonin. And a number of applications have been made for clinical trials that have been denied by the FDA. They don't explain why, and again, I'm not going to throw too many stones at the pharmaceutical industry, but the pharmaceutical industry determines what the FDA does for the most part. Mm-hmm. And of course, they make a lot of money from their vaccines and other treatments. You know, if melatonin could in fact reduce, and there's strong evidence that it would, reduce the likelihood of severe COVID infection, I think it would be very significant because melatonin is very inexpensive relative to other drugs. We did do one limited study in Manila, the Philippines, and we found that melatonin in humans, and melatonin in that situation was very effective in reducing the signs. There's a clinical trial that's just been completed in Madrid, Spain, by a former postdoc of mine, Professor Dario Acuña Castroviejo. They have not released their findings yet, but all they've said so far is it's been very effective. But I don't know the details of the outcome, so I can't comment on that. But they gave IV melatonin as a treatment for very seriously ill COVID patients.
That's awesome. So, and I was reading something about its use in Ebola as well.
Yeah, any of these viral infections, we think melatonin would be, obviously, COVID or SARS-CoV-2 is a virus. We think would have been effective against MERS. We predicted it'll be effective against Ebola. We predict it'll be effective against the common flu. These are all viruses that treat the body and do not depend on anything else.
Well, so I guess if a person has the flu, they should be sure that they're on their melatonin.
Absolutely. I think it would be better to, in fact, take melatonin in advance. In other words, again, I'm not recommending everybody take melatonin. I've taken melatonin for 27 years because I know what it does. That doesn't mean everybody should do that. But
well, and you know, in the conference, I think you said you were taking at that time 180 milligram, but you backed off now to what, 75 or something like that?
Yeah, I'm at around 75, and that's much higher than the usual dose that is sold, except for you did provide the information on, say, 60 milligrams.
Yeah. So for the listeners, I had the same reaction you probably did, because when he said at that point he was taking well over 100 milligrams, I said, "My gosh, how many capsules is that?" And he says, "Oh no, you just buy it in the 1 kilogram size and you weigh it out on your analytical scale."
Yeah. I've also, since I've been in the melatonin field so long, a number of companies have sent me pure melatonin in powdered form, so I have a good stash of melatonin out.
But what you were alluding to, we do, after that conference with Dr. Schallenberger, he knew a lady who had a pharmaceutical company there in Carson City, Nevada, and so they now make melatonin 60 milligram from Scientific Health Solutions, and it's not very expensive. We sell that at our regular office and at the Ozone Clinic. Again, that Ozone Clinic number is 210-558-7778. That's O3plustx.com. If you need some melatonin, or if you need any of the other things that we talk about on the show. So let's see, what else? Something I read about was that the melatonin controls the sexual behavior of the animals.
Well, that's how I began in the field. I told you that, of course, melatonin is high during the dark. And under natural photoperiodic conditions, night length and day length change. You said on Sunday, we're going to go back to daylight saving time on that. And of course, on March 22nd, the day and the night length around the world will be 12 hours of light and 12 hours of darkness. But if you, at other times of the year, the night length, for example, in San Antonio, in the winter on December 22nd, the night length is 14 hours. And in the summer, the night length on June 21st is 10 hours. So there's a great variation. And that changes the amount of melatonin to which you are exposed, of course. Or at least if you're in a natural habitat and exposed to natural photoperiods. And that information signals time of year. And animals that are seasonal breeders adjust their reproductive cycle using that information. A good example is the deer. Deer are very common around San Antonio, but they are strictly seasonal breeders. The males rut in early December, and the young are delivered in the first week of June. And there's no variation on that, and they depend on photoperiod. Humans are not seasonal breeders. We are continuous breeders, and we also do something else that is very unfortunate. We contaminate our darkness with light. Light inhibits melatonin production. So, I'll give you another example. There are some parents who allow their children to sleep with the lights on because they're intimidated by darkness. That should never, ever be permitted. Never be permitted. You are just destroying your circadian clock, and you are suppressing the melatonin. Light pollution has become a major issue in terms of, for example, cancer. Light at night is considered a type 2A carcinogen by the World Health Organization because it's suppressing your melatonin. So the consequences of light at night is really very severe.
Does it matter what color?
Yes, it does. Thank you for asking. Blue wavelengths are maximally inhibitory. All white bulbs, white light, have blue wavelengths. In other words, it may look white, but it contains blue wavelengths around 150 to 180 nanometer light. So at least you should avoid blue wavelengths of light, if at all possible. An example would be, again, if you're going to use a night light in the children's room, it should not be white. It should be red or yellow, because then you do not have a blue wavelengths. So we can have light at night. We could have light at night as long as it didn't contain blue wavelengths. But all white light generally contains blue wavelengths. And now
this is why the people wear those blue blocking light glasses in the evening. Yeah.
Exactly. the individual who first developed them is at near Cleveland, I forgot, Kent University. I've never met the man, but he sent me a couple of his blue blocking glasses. So yes, blue block. Again, another good example is hospitalization. Obviously, hospitalization is very important if you're very seriously ill. I told you I arrive usually before 6 in the morning when it's still dark. I park next to the medical school, but I can see the hospital. 1/4 or 1/3 of the rooms have lights on. That should never be permitted. If you are hospitalized, or maybe all the time, you should wear eye shades during the night. Even if the lights are turned on, you are still in darkness. But if you do that, you cannot lift up to see if the lights are on. 1 second of light, 1 second of light exposure at night, if it's the right brightness, will in fact immediately suppress your melatonin.
For how long?
Good question. Good question. Depends upon if it's early in the night, middle of the night, or late in the night. Say, for example, you go to bed or you go into darkness at 9 p.m. If you turn the lights on at 10 p.m., your melatonin levels will go down, but they'll respond pretty quickly and go back up. If you do it at midnight, again, they'll go down, but respond more slowly. But if it's after 2 in the morning and you turn on the light, then they'll never come back. But even that is interesting. Think about what your clock is saying. Your clock has been taught throughout evolution that it's either light or dark, and it depends on that melatonin signal. When you turn on a light at night, your melatonin goes down, and your clock sees that. It says, oh, it's daytime. Very short night, but it's daytime. Now, you do that several times during the night, your clock is totally confused. It says, what's going on here? I've been told all during my evolution that it's either dark or light. And now somebody is exposing me to light at night. This brings up an issue for elderly people who get up to use the facilities at night.
Right.
They have to do that without turning on the light. They should know their environment well enough that they can get there without having to turn on the light.
Or have maybe red night lights along the way.
That's a possibility. Red or even yellow if it's not too bright. Yes, just as long as you avoid blue light. Ideally, for example, on December 22nd, I mentioned night length in San Antonio is 14 hours. If we were on the natural photoperiod, we'd have 14 hours to produce melatonin. But most of us do not have, I don't know of anybody who has 14 hours of darkness at that time. Usually, darkness only occurs when you're asleep, and most people do 6 to 8 hours per night. So that's the only time you have to produce melatonin. Not related to sleep, related to darkness. But the only time we're in darkness is typically when we sleep. But you absolutely should be in darkness when you do sleep.
Now, in one of the articles, it was talking about melatonin being associated with the mitochondria. And is it produced anywhere else, or is it only in the pineal gland?
Very good, Frank. You're up to date. About 6 years ago, in 2014, we speculated that melatonin would be produced in all cells in mitochondria. Mitochondria exist in all cells because they evolved from bacteria. And bacteria are the precursors of mitochondria in every one of your cells. So we said bacteria produce melatonin, maybe mitochondria do. We speculated that, but then it was very shortly shown by several excellent research groups, Professor He in China, Professor Friedlander in Pittsburgh, and Professor Quintela in Portugal, showing that mitochondria produce melatonin, and we have subsequently confirmed that. Mitochondria of every cell produce melatonin, but they don't do it in a circadian manner. They do it uniformly. What's important about this is your mitochondria are your primary site of free radical generation. During something called oxidative phosphorylation, a lot of free radicals are produced. Where better to have an antioxidant in high concentration than in the mitochondria? That's where the damage primarily occurs from free radicals. And here's old melatonin sitting there just waiting for these free radicals to be generated. So yes, and this is something else. The amount of mitochondria in a tissue varies with the amount of energy that is required. In other words, the amount of ATP. ATP is produced in mitochondria. Your heart has very high concentration of mitochondria because it's always working. And this is why it's sensitive to doxorubicin. This is why doxorubicin has so many mitochondria. Doxorubicin is taken up by mitochondria. Well, melatonin, if you take it, will go in there and also help to protect. So mitochondria vary. Your brain has a lot of mitochondria. Mm-hmm. And of course, neurodegenerative diseases seem to relate also to the amount of melatonin, your melatonin rhythm and the amount of melatonin you have.
So if your melatonin goes down, you're more likely to have free radical damage to your mitochondria, not make as much energy, and the energy drives everything in the body. So immune system, the energy you have, cellular repair, all the other things.
Absolutely. Mm-hmm. Absolutely, yeah.
So how can we naturally increase our melatonin besides uninterrupted sleep? Is there like a supplement? I mean, besides just taking melatonin, like you mentioned, tryptophan, does that actually...
Well, tryptophan would be inefficient. In other words, there's no reason, if you have a choice between tryptophan and melatonin, you shouldn't take melatonin. That's the final product. And a lot of, it's been espoused in the past that 5-hydroxytryptophan also be taken. And if people want to do that, that's fine. But there's no reason to do that if you're interested in increasing your melatonin. Just take melatonin. It's a totally non-toxic molecule and readily available. And like you say, not expensive, not relative to prescription drugs, not expensive at all.
Well, let's get into dosing. So in my family, let's see, my sister takes 20 milligram and she loves the vivid color dreams that she gets. My mom took 10 milligram and she had such dreams that people were chasing her and it was too scary, so she didn't like to take that much. But I thought in the talk you said at the higher dosages it doesn't do as much for dreaming and stuff. Is there any truth to that?
I think the dreaming issue is of interest, but remarkably, there's been many clinical trials on melatonin and sleep, many clinical trials, and never has dreaming been mentioned. And you would think those physicians would have recorded that information. Certainly, I know because people have told me they dream, and sometimes they're very, very vivid. My experience is, however, that with prolonged use of melatonin, those dreams subside. They disappear. For example, I've been taking melatonin forever, and I don't remember the last time I've dreamed, and I take large amounts. But some people seem to be susceptible. Now, why is that? There's several potential explanations, but we really have no idea why melatonin influences dreaming, which occurs during slow wave sleep. But there are people who experience that. I would suggest that if they want to, they should reduce their dose and go up gradually. In other words, start at 2 or 3 milligrams and then 3 months later go to 5 and so forth. Like when I started, when I was already in advanced stage, I wasn't taking 60 to 100 milligrams. I was taking the usual dose, 2 to 5, but over the years, on the basis of what I see melatonin capable of, particularly in terms of neurodegeneration, I want to be sure I have ample melatonin to prevent is a tough word, delay, make less severe certain diseases of aging.
if you, it would make sense, I guess, if you are ill. I saw different dosaging. So one of the, like the frontline doctors or whatever were recommending 3 to 5 milligram melatonin. But to me, it would seem like that would be a usual preventative dose. But if you actually have a virus attacking you and you have more free radicals being produced and everything, it's going to get used up pretty quick, wouldn't you think?
If you have COVID infection, you have what is called a cytokine storm, producing a lot of free radicals. 2 to 3 milligrams of melatonin probably will not do it. The clinical trials, for example, our trial in Manila, the Philippines, we gave 200 milligrams daily under those conditions. And the patients responded in terms of reducing the severity and reduce the length of time in the hospital. You are absolutely right. If you have a very serious disease like COVID, I always put the analogy as follows. You can't stop a fast-moving train with a wagon. You have to put something in front of it that will stop it. And a Volkswagen will not stop a fast-moving train. And that's what it is with these diseases. You know, you have to, under those conditions, you have to give larger doses, so far as we know.
Well, so I would love to be giving melatonin in the hospital, and but you know, right now you can't really put that on the order form. You just have to give it to the patient and tell them, take this, it's good for you. And, you know, it's not, I mean, the hospitals have all the rules. How can we get it approved? I mean, I know in other countries they have less rigid rules for what they give, and I understand that hospitals have liability issues and whatnot, but when you have all this data, is there a way around it?
I wish there was a way around it. You're right. It's not necessarily the physician's fault. There's something called standard of care. They can give toxic drugs. If the patient falters, it's a standard of care. But if they give melatonin and something happens, the physician would be, of course, liable. And even though the melatonin probably did cause it, it's not standard of care, and thus the physician has to be very careful. In reference to hospital utilization of melatonin, I had reason about 2 years ago to visit Duke Medical School in Durham, South Carolina, and I was surprised that in the evening, if a patient asks for melatonin for sleep, they give them melatonin. And in other words, all the patients have access to melatonin if they want.
But they probably don't have access to 60 milligram.
No, that's true. That's very, very true. They have access to 3 to 5 milligrams.
Which is probably helpful, but...
It's certainly helpful in terms of circadian rhythm, submitting sleep, but in terms of antioxidant, when you have any serious disease, 5 milligrams won't cut it. Let's give an example. Linus Pauling, who won 2 Nobel Prizes, recommended the use of vitamin C for a common cold. 2 grams, 2 to 4 grams, 4,000 milligrams. And we're talking about 2 to 5 milligrams of melatonin. You can't compete. You cannot compete. We definitely need more. I don't think we need 2 to 4 grams because melatonin is so much more effective. Mm-hmm. But you need more than 2 to 5 milligrams.
What things in the environment decrease our ability to produce melatonin besides light exposure?
Yeah. Unfortunately, a lot of prescription drugs, there are probably patients that are listening who are on a beta blocker for hypertension. Beta blockers will prevent the production of melatonin in the pineal gland. Benzodiazepines, a lot of prescription drugs will reduce the amount of melatonin produced. Also, of course, right now, the environment is filled with toxins. We breathe a lot of toxins. We eat a lot of toxins. And all those impact the amount of melatonin that we need. We just published, for example, we just published a paper with colleagues in Sao Paulo, Brazil. Sao Paulo, Brazil, largest city in the southern hemisphere, is heavily air polluted. Of course, it's caused a lot of damage to the lungs. Again, free radical based. When we expose animals to that pollution and gave them melatonin, reduced the amount of damage to the lungs. So a lot of things impact our need for melatonin, and certainly some things suppress its endogenous production like medications. But also you can eat melatonin. Anything you eat will have some melatonin.
Oh, because it's in the plants and the animals?
Yeah. And there are certain plants that are relatively rich in melatonin, usually seeds and nuts. You have to understand a seed as a nut is really the next generation of the plant. You must protect the seed or the nut if it's going to grow subsequently. And what these seeds and nuts do, they are endowed with a lot of melatonin to protect them so they can germinate. We also know that if you take soybeans, we did this study, we published it already 6 years ago with Chinese scientists. I have a lot of Chinese collaborators. Soybeans, every year there's 374,000 tons of soybeans produced throughout the world. We found that if you incubate the soybeans in melatonin solution overnight before they are planted, they will have a better crop yield by about 10%. Think about that. If you could increase the crop yield by 10% without increasing the amount of land where you have to plant them, that would be the equivalent of 37,500 tons of soybeans.
Wow.
Yeah, melatonin. I think plant melatonin research is actually advancing much faster than animal and human research, because you don't need approval. For any study that's done in humans or in animals, you have to go through a lot of rigmarole to get them approved. But plants, you want to give them melatonin, you throw some melatonin on them. So that research has progressed, and melatonin will become a big deal in agriculture and science.
You know, the nice thing would be if farmers would be using melatonin-enriched plants and seeds rather than using Roundup to enhance their yields, because that's messing up our gut biome and everything.
I'm not an expert on Roundup, but I know it's not very healthy stuff. Yes, I agree. I
like the natural stuff.
Yeah. Well, again, melatonin sprayed on plants increases their hardiness. So I can imagine, you crop spray them with melatonin and increase your productivity and decrease viral infection. Melatonin is antiviral in plants just like it is in humans or in animals.
Wow.
It's antiviral.
So for the listeners who have just joined, we're talking to Dr. Russel Reiter, PhD. He is an expert in melatonin, and we're trying to figure out how melatonin can increase our health and longevity. This is sponsored by O3 Plus Texas, our health and wellness clinic here in San Antonio, Texas. The phone number there is 210-558-7778. So, Dr. Reiter, how about using melatonin for longevity? What did your studies show?
That's an interesting proposal, because I'm just now writing a review on this subject. I think if you're talking per se longevity, I'm not so sure melatonin will prolong longevity, but it will in the indirect sense. For example, if you can reduce the progression of cancer, if you can reduce the progression of Alzheimer's disease, you will live longer, and more importantly, you will live healthier. And that's what's important. It's not how long you live. Obviously, we all want to live a long time, but your health is, if you live healthy, that's what's most important. Right. Obviously, if we can delay cancer, we can delay Alzheimer's disease, there will be a benefit in terms of longevity. But per se, increasing longevity, I don't think there are currently any studies showing that it will just automatically improve longevity. But it will reduce the diseases of aging that improve longevity and certainly improve the quality of life. I always said when when I die, I want to die of nothing. They say, why did he die? He just died. He said, well, he died of something. No, he died of nothing. That's the way I want it. I mean, obviously that's the goal of all of us. We want to live healthy. That's what's most important.
Mm-hmm.
And I think melatonin, I remind the audience that as they age, they will diminish their melatonin production.
Well, that's a good point. So should parents have children on melatonin, or you don't have to worry about it until they get older?
Well, depends. Interestingly, in the United Kingdom, melatonin is the most commonly prescribed drug for sleep problems in children. In other words, melatonin is often used in children, even though they have a lot of it. But children, again, light pollution, interruption of circadian rhythms and so forth. I'm not advocating that they give it to their children, but there may be a reason that they should under some circumstance. Childhood cancer, osteosarcoma, is one of those cancers, typically of teenagers, that responds well to melatonin. If I had a grandchild or a child with osteosarcoma, I would not shy. I would consult my oncologist, take their recommendation, and also ask them about the addition of melatonin.
Mm-hmm.
So,
what about, has it been explored in autism or anything like those?
There have been some studies on autism. Again, autism, of course, is becoming very, very common, and a reason for that is unknown, but it may relate also circadian rhythm disruption and so forth. Melatonin has often been given to autistic children, and a lot of parents report improvement. I'm not saying that is a fact, but
it won't hurt.
It won't hurt. It won't hurt. Yeah,
mm-hmm.
That's
the beauty of this, is that if you don't have a toxic dose, I guess. But some patients say that they feel groggy in the morning if they take too big of a dose. Is that true?
Well, I'm not saying it's not true, but if you have a group of 50 people and you give them all a placebo at night, but tell half of them they got melatonin, 30% of those people who think they got melatonin will be sleeping the next day. In other words, the placebo effect is a remarkable event in humans. If we take a sleep agent, we think we will see, many of us will be sleepy the next day. Sleepy, but not really sleepy. I'm not saying sleepiness is not a consequence. I have never been sleepy the next day. Most people are sleepy the next day because they don't get enough sleep.
Right.
Nothing to do with melatonin. I'm not saying some of them don't. But it may be a placebo effect. That's accusing them as it's in your head. And, I don't mean to do that, but there's a big placebo effect with sleep.
So we got about another minute and a half, and I wanted to just kind of reiterate what we were talking about. This is melatonin with Dr. Russel J. Reiter, Ph.D. from San Antonio UT Health Science Center. He's been studying melatonin for a long time. I believe melatonin was discovered when I was born 62 years ago. And so a final word, is there anything that people can do to help them adjust to this daylight savings time? Would melatonin help?
Almost every year at this time, either daylight saving time forward or backward, I get calls from individuals. Typically, a 1-hour phase shift will not cause a great circadian dysregulation, but there are some individuals who are very, very sensitive to that 1-hour shift, and melatonin will cause that. It's a type of jet lag. Like, Frank, if you fly overnight to Europe, you only have 6 hours of darkness. You get off the plane in Europe, you will have jet lag for a week. Same thing applies to this 1-hour time shift. Most of us will not be affected because it's just too small. But there are some people who are very sensitive, and every year, I suspect this year I will also be called when what shift is made.
Well, so I want to thank our guest, Dr. Russel Reiter from San Antonio, Texas. Thanks so much for being here, Russ.
My pleasure.
And I hope we can invite you again sometime. I know you had a book before that was written in 1996 or something, and
right.
Maybe we can get together and get an updated book with all this antioxidant information sometime.
Yeah. Thank you. Be happy.
All right. So thanks so much for listening. Again, this was from O3PlusTX.com, our sponsor, and this is Dr. Frank Cutting Edge Medicine Show, DRFRANK, cuttingedgemedicine.com to get more information. Thanks so much for joining us, and join us again next week. Hope you get some good sleep and adjust to that daylight savings time. Have a great week, everybody.
Thank you.